Assalamualaikum warahmatullahi wabarakatuh, and good day to each and everyone. So, in here we will gonna discuss about this subject is 66. Okay, so our topic for today is about um, transfer function models of LTI differential system. Okay, so this topic will be allotted for only 1 week, no? So starting from July 26 until July 30. Okay, so this gonna be a week 5, no? This will be our week 5 for this semester. Okay, so we have here once again transfer function models of LTI differential system. Now, so previously we have been discussed about LTI differential system. Okay, so this probably this differential system, LTI system, is to represent a complex um, complex feedback system in which you have to represent that system to have the different characteristic of the feedback system. Okay, so yun, so we have here transfer function models of LTI differential system. So I think we have you have already uh, an information regarding on Laplace transform, no? Okay, so I'm assuming that you have already, or some of your instructors have already discussed about this um, um, Laplace transform. Okay, so one way of, for your information, no, just a little bit um, discussion about that one. So for your information, when you say Laplace transform, we have to transform a function in which uh, into the other function which has a variable s, no? So that s is called as a uh, uh, complex variable in which we have to represent that as a function of an real numbers and imaginary numbers. Okay, so yun yung ibig sabihin nun. Okay, so now, so in this subject we will be using that one. Okay, that transforming function into Laplace transform to study the characteristic of the LTI differential system. Okay, so but before that, we let us first review what we have learned about that one. So we have here the Laplace transform. Okay, so in general, in order for you to transform a function into its Laplace equivalent transformation, you have to use this equation number 1.48. So we have to substitute the value of x of t in that equation and integrate it to find its equivalent Laplace transform. So for example, in this example number 1, we have a function of x of t is equal to e to the power of negative at u of t. So substitute that function into inside an integration. So and then integrate that once we have a total equivalent um, transfer function of 1 over s plus a. Okay, so therefore that 1 over s plus a is equivalent function or equivalent Laplace transform of this x of t is equal to e to the power of e to the power of negative at. Okay, so this would be the representation of that transformation. So we have here a real number, we have here a real axis and the imaginary axis, and this would be the function. Okay, so we have to transform that one in this rectangular form, okay, to represent that function. Okay, so yan yung example. Okay, now, so as for the any kinds of transformation, we have a so-called inverse transformation, no? So specifically in this Laplace transform, we have also a inverse transform of that Laplace transform. So it means that given your Laplace transformed function, we have to find out what is the equivalent function of that Laplace transformed function. Okay? So yun yung inverse. So it means that kukunin natin yung equivalent niya na function, yung Laplace transform na yun. Okay? So yun. So we have here also an equation to find that one. Same for the Laplace transform. This equation number 1.50. So in order for you to find the equivalent x of t, or a function in terms of time, you have to use this integration. Okay? So in here, kung meron kang given na x of s, just substitute that x of s dito sa loob ng integration, and then integrate that one. So makukuha mo na yung equivalent na x of t. So as you can see here, we have to integrate that x of s with respect to ds. So after we evaluate that one, so the resulting function would be as a function of time. Okay, so yun. So that's why this would be x of t. Okay, so yun. So somehow here, we have just the characteristic of that integration, but I will let you to read that one. Okay, so we have here number 1.3, we have okay, convolution property of the Laplace transform. Okay, another special properties of transforming a function, we have here a convolution property. Okay, so basically, this property only concerns about the transforming a function which has a property of which has a two function which is related to each other. So for example, in here, we have here x1 of t and x2 of t minus tau. Okay, this would be tau here. uh, x1 of tau and x2 of t minus tau. So we have here the relationship between these two functions, and then we have to transform that one. The resulting would be this one. Okay, so yun. So you have to follow this rule, okay, in order to find the transformation of that function. Okay, so yun. So this would be the convolution property of the Laplace transform. So we have here an example. Okay, so just read about this example. Okay, kasi nga it's just the representation of this property here. Okay, so now we have here time shifting property of the Laplace transform. Okay, so what ano naman to siya? Okay, so if we have a function of shifted time, so for example is this one here. Okay, wait lang, this one here, we have here x of t minus t sub o. So it means that the time function of this function na x of t is shifted at the t sub o na time. Okay, so ibig sabihin nun, naka-shift siya ng t sub o, amount of t sub o na time. So in order to transform that one into its equivalent Laplace transform, we have to use this rule. Okay, so we have to use this rule. So ang gagawin daw natin is to transform x of t itself, no, without considering the time shifted. Then after that, i-multiply natin siya sa e to the power of negative s t sub o, where t sub o here is the shifted time here. Okay? So, anyway, meron naman tayong pwede naman nating that is already an understandable naman. Okay? So, we will no longer have to discuss this one. Okay? Kasi understandable naman siya. So, number 1.5, we have here the Fourier Transform. Okay? So, the Fourier Transform is actually have been discussed on our ES 12, no, or the Advanced Engineering Math, basically. No? So, when we talking about Fourier Transform, it means that we have to transform a function of time into an equivalent, same as equivalent complex function then, pero in here we have to take the effect or result of the um what do you call this one, result of the sine and cosine function. Okay, So yun, so that would be the result of transforming sine and cosine function in terms of time. Okay, so in order to fulfill that one, so we have to use the equation 1.6 and 1.61. Okay, so kung makikita natin dito, meron tayong function of x of t here, x of t. Then in order to find its equivalent Laplace transform, we have to use this one. Okay, then after this, itong resulting na to rito, isa-substitute natin dito sa formula na to, then that's it. That's already the Laplace transform or Fourier transform of the equation. Okay, na given. So once again, no, kung meron kang given na x of t, so we have to find out this one using this equation, and after that, the result will be substituted here sa x of t, then that will be the resulting Fourier transform of the function. Okay, so we have here 1.6, the transfer function of LTI system. So same lang naman sa discussion na taas. So just read about that one. So what I'm gonna discuss here is only the um, on how to transform a function, but I will left you to study or read about this stability, the transfer function of the differential system, and transfer function of the state space system, kasi these are just a discussion or a continuation or an application of previously discussed na transformation sa taas. Okay, so yun. So once again, starting from this here, wait lang, starting from this here sa stability until the end, this is just an application of our transformation or Laplace transformation na diniscuss ko dito sa taas. Okay, so just read about this one, no? So once again, if you have any question, kindly, okay, propagate it to me right before this discussion so that we can directly answer it, inshallah. Okay, so that's all. Assalamu alaikum warahmatullahi wabarakatuh.